Hello everyone and welcome to this new tutorial from blendercookie.com. My name is Thomas Pimontes and today I will guide you through the process of creating a regular tornado in Blender using the smoke simulator. A tornado such as this one you see here, which can also be used in your animations. The reason why I'm calling this a regular tornado is because there are many types of tornadoes, size and shapes, but this one features the main elements you may find in many of them, such as the column, you can see here, so coming from the sky and reaching the ground. Then comes the wind effect on the ground, as you can see here. Then the cloud, which is actually rising up, according to reference videos, that the wind pushes up the smoke from the bottom to the top. Finally, the effect of the forces on surrounding objects. As we are using force fields to generate the twister, they can also be used for various tasks, just like this. So let's go ahead and create our tornado. I will close my window and follow with a new startup. Okay, so first things to do, we will create the column, which is basically the main part here. Let's delete the default cube, press X and delete. And now we'll add a new circle, press Shift A and circle. In the options here, we will choose to fill the circle, so that we are left with a sort of circular plane. Now we need to scale it up using S, but to be more specific, I will press S and 2 on the numpad, so that now we just double the size of the object. The same way, we will move the circle up to 8 Blender units, so 8 squares. Press G plus Z plus 8 on the numpad. And the only reason why I'm doing it this way is just for you to know exactly where I'm placing the object. So now let's rename the circle, twister underscore top. Okay, we are now ready to add the first particle system. So in the particle systems panel, press the little plus sign here, and I will also want to rename it twister underscore top. Okay, so if I start the animation, pressing Alt A, you can see that the particles are just falling down, and this is not really what we want. And more than this, we won't really use the setting here to animate the tornado. So in the velocity setting here, set the normal velocity down to 0, and now find field weight here, and change the gravity down to 0 as well. And now the particles shouldn't move anymore. Alt A to launch the animation. It's okay there. So let's add more particles. 5000 should be enough. But now our particles will all share the same velocity when moving down later. We will just add a little randomness. In the velocity panel, set the randomness to 0.5. So the particles starting down will fall faster than the ones starting upward. Let's move the cursor back at the beginning and add a cone effect to the motion of the particles, just like this. To do this, press Shift A, force field, and force. If I press Alt A again, my particles are being pushed away by the force field. What we want is the contrary. So in the physics panel, let's change the strength to a negative value. -15 is good. Now the particles are attracted by the force. So now the force acts like a target for the particles. And now they may be going too far from the center. To see this a little better, I will increase the draw size of the particles. So particles, find display, and change the draw size. So now we see a little better. And to correct this, we can adjust the flow setting here, which is supposed to convert the force into airflow velocity. But just remember that now the particles will just be trapped closer to the center. So I will just set this to 1. Now we are done with the conical shape of the tornado, and we need to add a rotation motion to the particles. Press Shift A, force field, vortex. You can't really see any change now, so let's increase the strength. Let's say 8. So now they are rotating, but the shape is not that great. we would like the bottom to be smaller, and also to lose this sort of straight line motion. And then again, it's done by changing the inflow value, let's say 1. You start to see the result here. What if I increase it even more? Well, the vortex will really attract the particles. So let's change it back to 1. Okay, so now the thing we would like to correct is this sort of wave effect from the vortex. This is too much irregular, and to counter that, we'll use another force field to change the aspect, Shift A, force field, and magnetic. In order to show you what the magnetic force field does, I will move my vortex and force in another layer, and choose another layer. So now, if I reset the animation, you can see the effect. I will increase the strength also. The magnetic force field is supposed to simulate the force of magnetism, and if you wonder why we are using this, it's because it will have a significant effect on our vortex. So let's bring back our force and vortex, and move to first layer. You can see that the animation changed, but still it's not over yet. So I will move it up to have something clearer. Okay, so around the middle of the column, and change the strength to 6. Okay, so and here I will replace point by plane. So this force field won't affect the z-axis anymore, and you can see that we have a nice twister. I will also change the flow up to 1 to change the look this way again. And finally, we can adapt the lifetime of the particles to stick to the scale of the tornado. And let's say 75. Okay, let's see. And perfect. So now if I select my force fields with Shift and right click and move them away by pressing G, you can see that the twister is following pretty naturally with a nice distortion. Okay, so the column is now over. And now what we want is to add a wind effect on the ground. So to do this, add a new circle, Shift A, circle. Okay, so you don't want it to be filled now, so deselect fill. We will scale it up. So let's say S and 2.5 on the numpad. Okay. And we want to create a ring, so tab into edit mode, press E and S to scale it down. Okay. And now we can add a new particle system. But first, I will rename it. So let's say twister underscore ground. Okay. So add a new particle system now. And increase the number of particles up to 2000. Okay, so this is what it looked like if I start the animation. And once again, we need to stop the gravity, field weight, and set the gravity down to 0. And as you can notice, we just can't use this force field to create a different animation. So we will move this emitter into another layer, M, and choose the second layer. Now my particles will act like they should. And if I choose to display also the first layer by pressing Shift and clicking on the first layer, you can see that the force fields are not affecting this layer. So force fields only affect their own layer. If I move it back to the first layer, it's moving. Move it back, not moving. I just hope you understood what I just said. And now, if you want to know why some particles are going up and others are going down, this is because when we extruded and created new faces, let me display the normals here. I guess Blender didn't know which side the faces were supposed to point at, so it gave them random directions. So I could change this by selecting everything with A and recalculate the normals. All the particles should move this way, or changing their side, but I won't do it, and undo the changes with Ctrl Z, because I think this will give us more variety on the particle motion. Okay, so let's go ahead and start to set things up. And first, we will add velocity on the z-axis. So here, up to 1. And now the particle moving down will just stop, because the normal is set to 1 as well as the z, so the velocity is cancelled. And still, I will add a little randomness here, 0.5. Okay. Okay, and so now we are ready to add a new force field. So Shift A, force field, vortex. You start to see the effect here. By the way, I will increase the drawing size a bit, so we can see a little better. You can notice something a little weird now. The vortex animation starts only around now, and this is because when I played the animation, Blender recorded the motion into the cache. You can see this here, the red line, with highlights each 10th frame. So until nothing changes into the particle settings, the cache won't be updated and will replay the previous animation ever and ever again. For example, if I modify a value, let's say the velocity, all the highlights after this frame disappear, and now Blender will update the animation as the cursor is moving. So let's keep going. Just like for the column, we will start to set up the vortex force field. So move into the physics panel. Well, select the vortex. And I will change the strength up to 6 and the inflow up to 1.5. Then again, we will need something to smooth the animation. If you know what I mean, I'm talking about a magnetic force field. And why not using this one? What if I want the force field to influence 2 layers? Then I'll just press M, and with Shift pressed, click on the second layer. So now the magnetic force field is inside these 2 layers, and it will affect both particle systems. Here the vortex is a little bit larger. We just need to adapt the rotation a little. How? Well, I will move in front view, 1 on the numpad and 5, and select the vortex force field, and pressing R, I will rotate it just a little, this way, and now we have some sort of random start in the outside, transforming into a clean rotation in the inside, just like this right here. If I select also the first layer, you can notice that the wind on the ground starts too early. We want to give the illusion that the wind starts only when the column is close enough from the ground. Right now, select this here, and just change the starting frame, let's say to 40. Also, I will change the lifetime to 150. So now the twister comes down, and then create this wind effect. So if I select all of this by pressing B to box select, B, and then move it away with G, my particles are following pretty nicely, but you don't necessarily want to animate it all the way manually, but maybe automatically. Again, I will select all the bottom part, so B to box select everything, and with Shift press select the force to be the active element, and then Ctrl P to parent it all to the force. Now I just need to move the force and everything will follow. Okay, So now, to animate it automatically, I will move it to the first frame here, and select my force field, and press I and add a new location keyframe. Okay, open a new window, and select the graph editor, and here we can see our location keyframes. For the X, Y, and Z axis, we don't need the Z one, so you can select it and delete it with X. My keyframes are here. We can't really see them as the curve is all flat, nothing's changed. To add a random automatic animation, we will open this side here, and watch for the modifiers button here. First, let's select the X location keyframe, click on Add Modifier, and select Noise. Now my object will move by itself randomly on the X-axis, according to this curve. But this is not really what we want. First we need to slow the motion down, and this is done by changing the scale value here. Now this is moving slower, so I'll set this value to 45. Okay. Now if I want to increase the effect, I'll have to increase the strength value here. So now we have a much bigger motion, as you can see here. So I will set this to 2.6. Then we have the phase, allowing you to change the shape of the curve whenever you need a different animation. Like here, the curve is going down, so this is a negative value for the motion, so the object will move that way, -x. And here, the curve goes up, so the object will move in the opposite direction. If I change the phase, here, positive, negative, the position will change according to this curve, but I will leave this to 0 for now. The last value is the depth, obviously giving more depth to the curve, but you won't need it either. And so this is it. This is just what you need to do to create an automatic animation. But again, the particle's motion isn't updated, because the cache recorded the previous animation. So again, I will change the setting inside the particle system settings, let's say the velocity. Okay. Now the cache is empty. So now I will reset it like it used to be. And now the particles are moving according to the force motion. So we will do the same for the y-axis. So let me open this bit. Okay, add modifier, noise, set the scale to 45 and the strength to 2.6. And the problem now is that the force will always move in the same directions, and the reason is because the curves are exactly the same, but if I change the phase here, the curves are now different from one another, and the object will move in every direction. Okay, so we won't need this anymore. So this little movement is giving a little more life to the twister, like it just don't need you anymore to exist. So we are now done with the particle systems, and ready to use the smoke simulator. And what you have to know about these particles is that they will act like drivers for the smoke simulator. So to use the smoke simulator, we'll need a domain, Shift A, Mesh Cube. Okay, so I will rename it Smoke Domain to be even more accurate than accuracy itself. Okay, and now we will scale this up. So S and 4 on the numpad. Move into front view and press Z for wireframe view. Move this up a bit, and we want to match a little more than our particle simulation. So scale it SZ like this. And so this will be our domain for the smoke simulation. Talking about smoke, let's move into the physics panel. Activate smoke, domain. Select our first particle system. Activate smoke flow. So the smoke will be emitted from the particle, keeping this shape. And do the same here. Smoke flow. And now if I press Alt A to start the animation, I should already see the smoke coming, but still the result is not that great, and this for many reasons. The first is that the smoke won't disappear just like the particles, it will just stay there, giving us a big smoky twister, and as we have many particles that keep coming, this is even more smoke coming. You would like the smoke to dissolve as it appears, and good for us that you can select this little box here called dissolve, and now you should see that the result is far more concentrated. And obviously this is not really detailed now, so let me speak about a few smoke settings, about the quality of the simulation. Here you have the resolution, which corresponds to how detailed the smoke simulation is, and don't do what I will do for now. If I double the resolution, the simulation will become more and more slower, and usually it's a bit more faster, because right now I'm recording this video, so this is being really slow, but I just can't do this real time, and we'd better do a bake. And this will also depend on your own computer. And oops, my computer just can't take more of this. So now you've just experienced what it is to play with high-res real-time, and the reason why I told you not to do this is because I did what is wrong, because when you work with simulation you first want to optimize your setup. So what I'm gonna do, I will change the resolution back to 32, and I will move this into another layer, other layer, and what you see here is that Blender also had to calculate the motion for the particles at the same time. This way you're not really doing economy for your systems. Let's say if I move this here, Blender will always have to calculate the motion. So never forget that when you think your particle settings is over, you'd better bake it. So in the cache section of the particle settings, here, click on bake. It may take a few seconds now. Do the same here. Okay, so now the animation is cached, and Blender will leave it as it is without adding more calculation time for this. So if I move this now, it doesn't care. So undo this, Ctrl Z, and as long as your scene is not over, you will probably want to test with minimal values, for example using less particles, and save it for the final render. Okay, so now I will come back to the smoke domain, which is in another layer. As you can see, if I play the animation, the smoke will occur, although this is not in the same layer than the particles. And this is okay, because as the smoke simulation is also affected by force field, this will allow you to again use other force field to influence the simulation, and not necessarily the same than in the first layers, because the smoke is supposed to act differently. And now the particles emit smoke, and the smoke just acts like smoke, rising up like this. Okay, so let's move the cursor back to the beginning. If I move it back here, the smoke acts just like the particles, and you won't have this rising smoke anymore. But now the animation is wrong, because you would like the smoke to move up instead of going down just like the particles. So just like the ground wind before, we don't want to use the same force field to animate the smoke. So I'll just move it into its own layer, and from the videos I've watched, the cloud is coming down, but the smoke is supposed to rise up to the sky in a circular motion. So the particles are only here to influence the animation and the shape, but the true twister animation will come from the smoke itself. Now we will have to make some adjustment, because we are supposed to have two different smokes, the cloud and the wind effect on the ground. because the wind effect on the ground is too heavy and we want it to be much lighter. So move into the wind layer, select the mesh, and decrease the density scale, for example 0.5, and now we have something less massive. Not less massive than expected. So I will decrease again the density scale, let's say 0.1, okay. So this is a way to add various smokes inside the same domain, and now this is really lighter, so I will just change this back to 0.5, and still the smoke simulation is really acting like smoke, just rising up. We will add some new force field, and instead of adding a new one, I will just copy the one from the wind effect. So select it, duplicate with Shift D, and press M to move in the smoke domain layer, click OK. Now I just have the same moving vortex, already parented. By the way, I shouldn't have duplicated this one, let's just reset the rotation, pressing Alt R, okay. So again, my vortex is already moving, like the other ones. One less thing to do. So I will increase the strength to about 12, and also invert the inflow. So the vortex does not attract the smoke. Set this to -1, not -10, but -1. And so the rotating motion is moving up and not down. The twister is like trapping the smoke upward. Also the animation is maybe too clean at this point. You don't really feel the effect of other wind and such, just like turbulence. So we will add a turbulence force field. So Shift A, force field, turbulence. Again, I will move this away to have something a little clearer, which will give some random motion to the smoke. Let's try with 15. And now it just looks like the vortex feels less under control. You can start to feel the wildness of the twister, but maybe too wild now. I will decrease the value to 5, should be okay. And finally, we will again need something to give a little more structured shape. And I'm still talking about the magnetic force field again. So we will have to find it here. And move it also in this layer. So M with Shift pressed, select also the smoke layer. So now it is in the 3 force field. And as you can see, the result is a little different. It sticks a little more to the particle's shape. And this is a little cleaner, by the way. So we are almost done with the simulation. So I will try and see what it looks like for now. And now what's happening is that my vortex comes down, with the smoke rising up in a circular motion, attracting what's on the ground to the top. And we can see that the real speed, and we can't see the real speed because I'm always caching this animation, but you may notice that this is going way too fast. To slow it down a bit, I will select my domain and find the time scale value here. This basically defines the speed of the simulation. If I change this, let's say to 0.2, the animation will be processed at 20% of the original speed. And now it still looks a little fast, and this is because of the particles, because they are still moving like before. So if I want, I can also change the speed of this simulation into the particle system settings, decreasing the time step value here, but I would have to rebake it. So what you see here, so this motion here is also here, and this is also great because the smoke sim can act at a lower speed, and giving us maybe various effects. But then again, it really depends on what kind of model you want to achieve, whether if it's a really big tornado or a small one. And here we are dealing more with a small one, judging from the smoke trail here. So if you want a bigger tornado, you will have to slow down the animation of the particles and the smoke simulation. So lastly, I will reset the timescale value to 0.5. And this will be the end of the first part, in which we focused more on the simulation. And in the second part, I will show you how to set up the material and some tips for the environment to interact with the tornado. So see you in part 2.